Today I want to go over how we can solve polynomial inequalities. The first example we are going to look at is x minus 1 cubed times x plus 2 squared times x minus 3 is less than or equal to 0. So the first thing that you want to do whenever solving a polynomial inequality is set it equal to 0. This makes it easy for us because then we just are trying to solve when it's equal to 0 rather than a different number. So here, that's nice because when it's equal to 0, we can just take each factor and set it equal to 0. And when we do that, we can find the zeros, or the x-intercepts, of the function pretty easily, which here will be at x equals 1, x equals negative 2, and x equals 3. So what I usually start out doing is putting these values on a number line, and I know that on my graph these are going to be x-intercepts. Now you can pause the video and type the equation into your graphing calculator if you want, but I'm going to talk through how we can think about what the graph will look like just based on the equation, to get just a rough sketch of the graph. So if we look here at all of the x values, notice that all of them have a leading coefficient of 1. And so what that means for us is that means the leading coefficient of our graph will be 1. And so it has a positive leading coefficient and it will end in the positive direction. Then what we can look at is we can look at the degree on each factor. Notice here at the x minus 3, this has a degree of 1, or it's just a single 0. And so when it's a single 0, it goes straight through the graph. Then if we look at our 0 at 1, the x minus 1, notice the degree of that factor is third power. And so with our third power, what happens with the graph is it goes through and it just kind of does its flattening out, but it still goes through. So we would get some curve at the bottom, then it would kind of curve, flatten going through at 1. And it would probably go up like this. Then we know it has to come back down around negative 2. And if you look right at negative 2, or x plus 2 at our factor, the degree on this factor is a squared. And anytime it's an even degree, it will have a turning point right at the 0. And so our graph, we know, will go up and turn right through there at negative 2. So this is just a really rough sketch of what the graph would look like, but we can use this sketch in order to help us figure out when the graph is less than or equal to 0. So less than or equal to 0 is going to be anywhere where the graph is equal to or below the x-axis, or below our number line here. Okay, so what I'm going to do as I go through is I'm just going to go along the x-axis, and when I get to a point where it hits the x-axis or it's below, then I'm going to shade it in with this highlighter. So notice here at 1, it drops below until we get to 3, and then nothing else on the graph is below. So we just have a few things that are highlighted, and that will help give us our solution. So notice right at negative 2, it includes just the negative 2 because it's equal to 0. So there's no interval there, just the negative 2. Then if we keep going along, notice there at 1 again, it's equal to 0. But then all the way from 1 to 3, it's below. And I can include 0, and that's why I'm using brackets. And then as I finish past 3, it never goes below again, and so my solution will just be x equals negative 2, or x equals a value between 1 and 3. Okay, let's look at one more example. Okay, here's a second example for us to look at. What we're going to do here is, just like before, we're going to first set the inequality equal to 0. So I'm going to move the 4x cubed and the 10x to the other side of the equation. And then I'm just going to write it in standard form. So I have x to the 4th minus 4x cubed minus 3x squared plus 10x, and that is supposed to be an 8 there at the end, so plus 8 is greater than 0. So this one's a little bit different from before because it's not in factored form. So if you wanted to try to factor it, you could, but I think probably the easiest thing to do, since we're comparing it to 0, is going to be to look at your graph and find any x-intercepts that you can on your graph. So pause the video for a moment, type it into your y equals on your graph, and find any of the x-intercepts from your graph. When I typed it in to my calculator, I had x-intercepts at -1, 2, and 4. And so what I like to do is label those on a number line. And it's just a rough sketch, so that's why I'm just putting in those values. And then using the graph, or you can again look at the equation, but sketch just a rough picture of what this graph looks like. So when I look at the graph, it starts with a positive end behavior to the left. Then at -1, it must be a double 0 because it just has a turning point right at -1. Goes up really high, down through 2, down very low, and then up again through 4. So that's just a rough sketch of what our graph will look like. But using this graph, we can now compare and find out when it is greater than 0. So this time, with this example, we want it to just be greater than, which means anywhere where it's above the x-axis. So I'm going to start tracing here because it's already greater than 0. So I'll highlight, and then notice I'm not going to include -1 because we just want greater than. So I'm breaking, but then it is greater than again until we get to 2. Then it falls below, and then at 4, right after 4 again, we get a section of the graph that's greater than. So we have the highlighted portion here at the top, and from that we can solve and write our intervals. So x is going to be greater than 0 starting at -infinity. So we're reading from left to right. So -infinity is over here. And then we go all the way until we get to -1, but we don't include -1. There's just a break there because then again at -1 it's greater than until we get to 2. But again we don't include 2. Then it's below the x-axis until we get to 4. But at 4 it's not included, so we do a parenthesis, and then the rest of the graph will be above the x-axis. So it will be from 4 to infinity. So 3 different intervals is what should be included in the solution for this problem.